Hi students and friends, this is your host and teacher Sayyid Ayaz Haider and you are watching Learn and Teach by Sir Ayaz. So I was doing past papers and this time I have selected for 5070 variant 22 and the session is May-June 2023. I'm not going to discuss the time, marks and other formalities for this paper as you all are aware of it. So straight away, let's start the paper. So here's the question number 1. Choose from the following oxides to answer the questions. These are the oxides. Each oxide may be used once, more than once, or not at all. State which oxide is neutral. You see, in these oxides, we have only one neutral oxide. Oh, we can have another neutral oxide also. We have two neutral oxides for this question. You can either write H2O or CO. Both of these oxides are neutral. B. Reacts with calcium oxide to form slag in the blast furnace. Now, in the blast furnace, silicon dioxide, SiO2, reacts with calcium oxide to form slag. This is the reaction CaO plus SiO2 and we will get CaSiO3. This is calcium silicate, also known as slag. So you will write SiO2. Number C, reacts with warm dilute hydrochloric acid to give a blue colored solution. Now copper 2 plus ion gives blue color solution. Now let's see if you have any compound of copper here. We have the oxide of copper here, that is copper 2 oxide. This is copper 2 oxide. So this oxide will react with warm dilute hydrochloric acid to give a blue colored solution. So you write CuO. D is amphoteric. Among these oxides, we have only one amphoteric oxide, and that is ZnO. This is zinc oxide, and it is amphoteric. E contains an ion with an oxidation number of +3. So if you look at the oxides here we are having carbon monoxide CO, carbon dioxide CO2, calcium oxide CaO, copper 2 oxide CuO, iron 3 oxide Fe2O3. Then we have water, sulfur dioxide SO2, silicon 4 oxide SiO2, zinc oxide ZnO. So Fe2O3 is iron 3 oxide, and the name implies that the iron ion here must be carrying +3 charge. As you know that oxygen carries -2 charge. So Fe2O3 will be the answer for this question. Fe2O3. Number F, decolorizes acidified aqueous potassium magnate 7. If you see these oxides, there is only one oxide that decolorizes acidified potassium magnate, which is SO2. Because during this reaction, SO2 will get oxidized further into SO3 when you react it with acidified aqueous potassium magnate 7. So you write SO2. Question number 2. Group 7 includes the elements fluorine, chlorine, bromine, and iodine. A. Chlorine is a green gas at room temperature and pressure. State the appearance of iodine at room temperature and pressure. You know that iodine is solid at room temperature pressure and its color is gray black or purple? Gray black or purple solid. B. Chlorine reacts with aqueous potassium iodide in a displacement reaction. Here's the reaction: Cl2 aqueous plus 2I minus aqueous gives 2Cl minus aqueous plus I2 aqueous. Number 1. Explain in terms of electrons why chlorine is an oxidizing agent in this reaction. Now, what is oxidizing agent? Oxidizing agent is the one which oxidizes the other reactant in this reaction and reduces itself. Now they are saying explain in terms of electrons why chlorine is an oxidizing agent in this reaction. So if you look at this change carefully, Cl2 to Cl minus, it means chlorine must gain one electron because the oxidation state or number on Cl2 is 0. So oxidation number or state is decreased from 0 to -1 due to gain of electron. So you'll write Cl2 gain electrons. B. State the oxidation number of iodine in I2. Now you don't see any kind of charge on I2, so it must be carrying 0 charge. The answer will be 0. Number 3, describe what is observed during the displacement reaction. The reaction is an example of displacement reaction, as they have already mentioned. So what you will observe, there is a change in color. The change in color is due to the formation of iodine in the solution, and the solution turns to brown. C. The rate of diffusion of fluorine gas is greater than that of chlorine gas under the same conditions of temperature and pressure. Number 1, state what is meant by the term diffusion. It's simply net movement of particles from higher concentration to lower concentration. Net movement of particles from higher concentration to lower concentration. Number 2, explain why the rate of diffusion of fluorine is greater than that of chlorine under the same conditions. Simply refer MR of fluorine or chlorine. In this case, fluorine, if you will compare the MR of fluorine and chlorine, look at the position of fluorine. Here is group 7, we have fluorine and chlorine. If you look at their mass number, fluorine is 19, chlorine is 35.5, and you know that they all exist in the diatomic state. So you write F2 and Cl2. MR for F2 will be 2 multiplied by 19 gives 38. 38 is the MR of F2. What about chlorine? It's 2 multiplied by 35.5. You will get 71. You can clearly see that the fluorine has lower MR than chlorine. So you write fluorine has lower MR or relative molecular mass than chlorine. Number 3, the rate of diffusion of fluorine increases as the temperature increases, such as why using ideas about kinetic particle theory, particles have more kinetic energy. Or you can even write particles move faster. Number 3. This question is about the preparation of salts. A. Zinc nitrate is a soluble salt. It is prepared by the reaction of an insoluble carbonate with a dilute acid. The equation for this reaction is shown. This is a reaction ZnCO3 solid plus 2HNO3 aqueous gives ZnNO3 whole twice aqueous plus H2O liquid plus CO2 gas. A sample of 4.5 gram of zinc carbonate is added to 50 centimeter cube of 1.3 mole per dm cube nitric acid. Number 1, show by calculation that the zinc carbonate is in excess. The best way of doing this kind of question is calculate the moles or convert the mass or the volume and concentration given in the question into moles. This will be the best route. So for ZnCO3, first of all, I need MR of ZnCO3 so that I can convert this into moles. So we have MR of ZnCO3. Here we have one atom of Z. So 1 multiplied by, where is Zn? Zn is here. Ar, mass number is 65. Carbon, we have one carbon atom. Its mass number is 12. What about oxygen? Oxygen is group 6. Mass is 16. So 1 multiplied by 65 plus 1 multiplied by 12 plus we have 3 atoms of oxygen. So 3 multiplied by 16. What you will get? You will get 65 plus 12 plus 48. So the MR for ZnCO3 will be 65 plus 12 plus 48, 125. Now, in order to calculate the moles of zinc carbonate, moles of ZnCO3, we need to divide the mass by the MR. 4.50 divided by 125. .5 divided by 125. 0.036 moles. 0.036 moles of zinc carbonate or ZnCO3. What about HNO3, that is nitric acid? We have 50 centimeter cube of 1.3 mole per dm cube nitric acid. So you must have same unit for the volume. So I'm converting this dm cube into centimeter cube. We know that 1 dm cube is equal to 1000 centimeter cube. So I will write 1000 centimeter cube contains 1.30 moles of HNO3. Therefore, 50 centimeter cube contains X moles. So we'll get X 1000, X is equal to 50 multiplied by 1.30, or X is equal to 50 multiplied by 1.30 divided by 1000. 50 multiplied by 1.3 divided by 1000. 0.065 moles of HNO3. These are the moles of HNO3. These are the moles for ZnCO3. Now, according to the reaction equation, one mole of ZnCO3 reacts with 2 moles of HNO3 So therefore 0.036 moles reacts with X moles of HNO3. Do the cross, we will get X is equal to 2 multiplied by 0.036. This will give us the moles, reacting moles of HNO3. 2 multiplied by 0.036. And we will get 0.072 moles of HNO3. Now compare this. Compare these moles with the moles obtained. These moles are higher, which means we need higher number of moles of HNO3. The requirement for the moles of HNO3 is higher than the one given. So it must be limiting. Hence it is proved that zinc carbonate must be in excess. Hence zinc carbonate is in excess, which also means that the moles for ZnCO3 is higher than the one which is needed for reacting with 0.06 moles of HNO3. Number 2, once the reaction has finished, the mixture is filtered. State why the mixture is filtered. Definitely to remove excess or unreacted ZnCO3. Excess or unreacted zinc carbonate. Number 3, describe how to make pure dry zinc nitrate crystals from an aqueous solution of zinc nitrate. Very easy. You have 3 marks for this question. So write down the steps involved here. So what steps we are having? We have to evaporate the solution. Evaporate or heat gently. Next part will be crystallized or cool down. Last step will be dry in air or oven. Dry in air or oven. Number B, lead carbonate is an insoluble salt. It is prepared using a precipitation reaction. Name 2 aqueous solutions that react together to give a precipitate of lead chloride. Now you have to start with the soluble salt of lead. We have only one soluble salt for lead because we know that all chlorides are soluble except lead, mercury, silver. All sulfates soluble except बेसन के लड्डू. We have barium, calcium and lead. So you can't take sulfate. What about carbonate? All carbonates are insoluble except sodium, potassium and ammonium. Now we have left only with the nitrate. So we can take lead nitrate. All nitrates are soluble. So we'll take lead nitrate. One of the salt must be nitrate, or then you have to react with this any chloride of soluble chloride like sodium chloride, magnesium chloride, etc. You can take even calcium chloride. C, ammonium sulfate is a soluble salt. It is prepared by the reaction of an alkali and an acid. Name the alkali and the acid used. So for the alkali, you must be taking the one which contains ammonium ion. So it must be either aqueous ammonia or ammonium hydroxide. For acid, it must be containing sulfate ion, so it's sulfuric acid. Question number 4. This question is about compounds that contain magnesium and nitrogen. A. The formula for a nitrate ion can be written as N3 minus. This is the proton number and this is the nucleon number for nitrogen. Complete table 4.1 to show the number of particles in this nitrate ion. So the electrons, so it is carrying 3 minus, which means that it must have 3 extra electrons in this. So if you look at the proton number of this nitride ion, which is coming from nitrogen, the proton number is 7. And it is carrying -3 charge, which means that it must have 3 extra electrons. So 7 plus 3, you will get 10. So 10 will be the number of electrons for this nitride ion. Neutron, in order to calculate the neutron, subtract the proton number from nucleon number. 15 minus 7, you will get 8. What about proton? 7 must be the proton. B. State why the formula for a magnesium ion is Mg2 plus rather than Mg plus or Mg3 plus. Mg2 plus. Now look at the position of Mg. It's in group 2. Mg. Proton number of Mg is 12, which means it must have 12 electrons. Coming back to the question. Mg and Mg plus 2. Now, what is the difference between Mg and Mg plus 2? Is that in Mg plus 2, it has lost 2 electrons. The proton number of Mg or magnesium is 12, which means it has 12 electrons. If you write the electronic configuration, it must be like this: 2, 8, 2. So these are the 2 electrons in the valence shell. Now there are 2 options for magnesium. It can either take up 6 more electrons to complete this valence shell, or it can lose these 2 electrons to acquire the electronic configuration of inert gas, one of the inert gases. So in that way, it can attain stability. So in Mg2 plus, it is having 2, 8. So this must be the right configuration for this one. And in this case, it is having complete valence shell. Now, what happens if Mg loses 1 electron only? So it will carry Mg plus, and the configuration become 2, 8, 1, which must be incorrect, because in this way the valence shell is not complete. Now, next scenario, Mg plus 3. It means it has lost 3 electrons now. Configuration become 2, 7. This is also incorrect. The reason is that again its valence shell become incomplete. So this is the most feasible state for Mg2 plus. It has complete outer shell of electrons. The formula for a nitride ion is N3 minus. Deduce the formula for magnesium nitride. Now in this they are asking the formula for magnesium nitride. Magnesium, here is magnesium, Mg, nitride, it's N. The charge for nitride is given, it's 3 minus. What about magnesium? Look at the position of magnesium, it's here, group 2, which means it must be carrying +2 charge. So I will write +2 here. Ignore the charges, 2, 3. Now these subscripts will be exchanged. So we have 3 here, 2 here. The final formula must be Mg3N2. This is for the magnesium nitrite. The magnesium nitrate, MgNO3 whole twice, is an ionic compound. Predict 2 physical properties of magnesium nitrate. Now they are asking any 2 physical properties of magnesium nitrate. Any 2 from. So it must be in the solid state. So write solid state or high melting point, or you can even write soluble in water, soluble or dissolves in water. You can write conduct electricity in aqueous solution or molten state. Conducts electricity in aqueous solution. E. Calculate the percentage by mass of nitrogen in magnesium nitrate. Give your answer to 2 significant figures. So first of all, you need to know the formula for magnesium nitrate. It is MgNO3 whole twice. Now we need to know the mass numbers of these atoms in order to calculate the MR. MR of MgNO3 whole twice. So we have 1 magnesium, we have 2 nitrogen, and 2 multiplied by 3 is 6 oxygen. So here's magnesium. The mass number for magnesium is 24, nitrogen it is 14, oxygen it's 16. So 1 multiplied by 24 plus we have 2 atoms of nitrogen, 2 multiplied by 14 plus we have 2 multiplied by 3, 6 atoms of oxygen, 6 multiplied by 16. So we have 24 plus 28 plus 96. Yes. So adding up these, we'll get the final MR of MgNO3 whole twice, 24 plus 28 plus 96, 148. 148 will be the MR. So I want to calculate the percentage by mass of nitrogen. How many nitrogen? 2 nitrogen atoms. So we have to multiply 28 by 100 and divide it by 148 in order to get the percentage by mass of nitrogen. So 28 multiplied by 100 divided by 148. 18.918%. This will be your final answer. Question number 5. Carbon reacts with steam to make carbon monoxide and hydrogen. The reaction is reversible. The forward reaction absorbs thermal energy, which means it is endothermic. For your convenience, I am writing delta H is equal to plus sign. If forward is exothermic, backward must be endothermic. Delta H is minus. A. An equilibrium mixture is formed when the reversible reaction happens in a closed system. Number 1, explain why the reversible reaction must be in a closed system for an equilibrium mixture to be formed, so that reactants and products cannot escape. So that reactants and products cannot escape. If one of these will escape, you can't get the reversible reaction reaching to dynamic equilibrium state. Number 2, predict what happens to the position of equilibrium when the temperature is decreased and the pressure remains constant. Explain your answer. So they are talking about the position of equilibrium when the temperature is decreased. So when you are decreasing the temperature, it must be favor the direction in which there's exothermic reaction. So the equilibrium will shift towards the left hand or reactant side. Shifts to reactant or left hand side. Explanation: forward is endothermic, or backward is exothermic. You can even write, in order to minimize temperature decrease, to minimize temperature decrease. Next, number 3. Predict what happens to the position of equilibrium when the pressure is decreased and the temperature remains constant. Now, for pressure, you have to look at the number of moles of the gases. So we have 1 mole of gas on reactant side and 1 plus 1, 2 moles on the product side. For your convenience, I am writing it here. 1 mole reactant side and 2 moles on the product side. So if you decrease the pressure, it will move to the side where there will be higher moles of gases. So it will definitely shift the equilibrium to the right hand side. Equilibrium will shift to right hand side. Shifts to right hand side or product side. Just write the number of moles. We have higher number of moles on the product side. Higher number of moles of gases. Mention gases. You can also refer to the volume of gases on product side, or less number of moles of gases on reactant side. B. Predict what happens to the rate of the backward reaction when the temperature is decreased and the pressure remains constant. Definitely rate will decrease. Why the rate decreases? Because the particles have less kinetic energy, or less number of particles having energy equal or more than activation energy. Particles have less energy there will be fewer collisions. Involving particles with equal or more than the activation energy. C. Predict what happens to the rate of the backward reaction when the pressure is increased and the temperature remains constant. The rate increases. The reason is that you have more particles per unit volume. which means you have greater collision frequency. Question number 6. This question is about the energy changes that take place during chemical reactions. A. Nitrogen reacts with oxygen to make nitrogen monoxide. The reaction is endothermic. This is the reaction. N2 gas plus O2 gas gives 2NO gas. Draw on the axis provided in figure 6.1 the reaction pathway diagram for this reaction. Include labels for the axis, reactants, product, enthalpy change of reaction delta H, activation energy EA. The reaction is endothermic. So it means that product must be at the high energy state. So if first of all I'm going to label the axis. On the x-axis you have reaction pathway or time. Or time. On y-axis you have temperature, centigrade, or energy in joules. Fine, so the product will be at high energy state. So if this is the reactant, this must be the product. Now I'm going to draw the energy hump between these two. This is the energy hump. Now show the reactants. We have N2 plus O2 gives 2NO. N2 gas plus O2 gas gives 2NO gas. Now activation energy. Activation energy will be starting from the reactant point. This must be the activation energy and it's going till up the hump, energy hump. Let's label it. It must be EA and it's always positive. What about the enthalpy change of reaction, that is delta H? It must be between reactants and product. It must be there between these two and label it delta H and it must be positive for this reaction. Part B, hydrogen reacts with bromine to make hydrogen bromide. H bond H plus Br bond Br gives 2H bond Br. Calculate the enthalpy change of this reaction. Use the bond energies in table 6.1. This is table 6.1. We have H bond H and we have Br bond Br. We have H bond Br and bond energy in kilojoule per mole is given for all these three. So here I'm going to draw the reaction again. This involves the formation of HBr from H2 and Br2. So this is the equation. Get to HBr. In order to calculate the enthalpy change of this reaction, recall the formula. The formula is energy associated in breaking of bond minus energy released in making of bonds. So delta H is equal to energy needed to break bonds minus energy released in bond making. So we have HH bond 436, 1 mole of H2 molecule. So I'll write 436 plus Br 193 minus 2HBr. It means we need to multiply 2 by 366. So we will get 436 plus 193, 629 minus 2 multiplied by 366, 732. So the final answer must be 629 minus 732. 629 minus 723. So it must be minus 94 kilojoule per mole. Six 29 minus 732. Sorry, it's 103. It's minus 103. So this will be the final answer for this question. Number 7. Ethene, butadiene, and butadiene are alkenes. The displayed formula of ethene and butadiene are shown in figure 7.1. This is ethene and this is butadiene. A. State the general formula of the homologous series of alkenes. The general formula for alkenes is CnH2n. So I will write CnH2n. B1. Butadiene and butadiene are structural isomers. Number 1. State the meaning of the term structural isomers. Same molecular formula but different structure formula. They have same molecular formula but different structures or structural formula. Part 2. Draw the displayed formula for butadiene. Butadiene. There must be 4 carbon atoms in butadiene. 1, 2, 3, 4. And there is carbon-carbon double bond on second carbon. Whether you start from right hand side or left hand side, you have to place double bond between 2 middle carbon atoms. 1, 2, 3, 4. So it must be having double bond. Now let's saturate the bondings of all the carbon atoms. For this carbon atom number 1, 1, 2, 3, 4. Carbon atom number 2, 1, 2, 3, 4. Carbon atom number 3, 1, 2, 3, 4. Carbon atom number 4, 1, 2, 3, 4. And let's place hydrogen atoms. So this will be the final displayed formula for butadiene. C. Butadiene is an unsaturated hydrocarbon. Number 1. State why butadiene is an unsaturated compound. It must be having carbon-carbon double bonds. Contain carbon-carbon double bond. Number 2. State why butadiene is a hydrocarbon. It must contains carbon and hydrogen only. Contains hydrogen and carbon only. Moving to next question, part D. Butadiene reacts with steam in the presence of a catalyst and reacts with bromine. Number 1. Draw the structure formula of the product of the reaction with steam in the presence of a catalyst. Now recall, Butadiene is alkene. When alkenes are reacted with steam, we will get alcohol. So in this case, we must get butane 1-ol, butanol. So they are saying the structure formula of the product of the reaction with steam. So we need to draw the condensed or structure formula. There must be 4 carbon atoms. So on the left hand side, we have CH3, CH2, CH2, CH2OH. You can even place the hydroxide group on the second carbon. So you can write CH3, CH2, CHOH, CH3. So both are correct. Part 2. Draw the structure formula of the product of the reaction with bromine. So when alkenes are reacted with bromine, we'll get addition product. Alkene plus bromine, we will get dibromoalkane. So here we are having but-1-ene. So 2 bromine atoms will be added to carbon 1 and carbon 2. So the structure formula will be CH3, CH2, CHBr, CH2Br. Part E. Ethene is a covalent substance. Number 1, draw a dot and cross diagram to show the bonding in a molecule of ethene. Include only the outer shell electrons of each atom. So what I will do, first of all, I am going to write the molecular formula of ethene. This is the first member of alkene with the value of N as 2. This is the general formula for alkene, CnH2n. So the formula must be C2H4. So on the right hand side, I am going to show the key. We have 2 atoms, carbon and hydrogen. For carbon, I am using cross, hydrogen, I am using dot. We have 2 carbon atoms, and there must be double bond between these 2 carbon atoms, and there are 4 hydrogen atoms. So for each carbon atom, there must be 4 valence electrons. As you can see here, carbon belongs to group 4. It must be having 4 valence electron sharing with each hydrogen atoms, and 2 of the valence electrons of each carbon atom will share with each other. So there must be 2 electrons each coming from the carbon atoms. 1, 2, 3, 4. And for the right hand side, 1, 2, 3, 4. For hydrogen atom, use dot. 1, 2, 1, 2. So this will be the final displayed formula, final dot and cross diagram for ethene. Number 2, explain why ethene has a low melting point. Now they are talking about low melting point. It must be due to the presence of weak intermolecular force. So weak intermolecular force. Number 8, this question is about electrolysis A. The table shows some information about the electrolysis of 3 different electrolytes using graphite electrodes. Complete table 8.1 with the names of the products at each electrode. This table 8.1. The electrolyte is concentrated aqueous potassium iodide. what will be the product at anode and cathode? Now it's concentrated solution, so we'll be getting iodine at anode, not oxygen, because of high concentration of iodide ions. What about the product at cathode? Potassium is more reactive than hydrogen. K more reactive than H positive ion. So we'll get hydrogen gas at cathode. The other reasons is that K positive ion have high difficulty of discharge or low ease of discharge. You can apply the reverse argument for hydrogen. Dilute sulfuric acid, the products will be oxygen at anode and hydrogen at cathode. What about the product for molten lead to bromide? It's very easy. We'll get bromine at anode and lead at cathode. B. Give two reasons why graphite is a suitable material from which to make electrodes. So it's very easy. It's inert or unreactive, having high melting point and conducts electricity. You can write any two of these. So any two from inert or unreactive, conducts electricity, have high melting point. C. Aluminum is manufactured by the electrolysis of aluminum oxide dissolved in molten cryolite. At the anode, oxide ions react to make oxygen molecules. Construct the ionic half equation for this electrode reaction. So oxide ions, it will lose electrons to form oxygen molecule. So we will write O minus 2 gives O2 plus electrons. Let's balance the equation. So we're having 2 here and it must be having 4 electrons, 4 moles of electron on the right hand side of the equation. Number 9, a sample of clean dry air contains 0.04% carbon dioxide by volume. Calculate the number of molecules of carbon dioxide in 480 dm cube of clean dry air at room temperature and pressure. 1 mole of any gas contains 6.02 into 10 to the power 23 molecules. So first of all, I need to calculate the percentage of carbon dioxide. The percentage of carbon dioxide is given by volume. So I need to calculate the volume of carbon dioxide in 480 dm cube of clean and dry air. So 0.04 multiplied by 480 divided by 100. 0.04 multiplied by 480 divided by 100. So 0.192 dm cube. 0.192 dm cube. This is the volume of carbon dioxide. You know that 1 mole of any gas contains 6.02 into 10 to the power 23 molecules. So first of all, we need to convert this volume of carbon dioxide into moles. So at RTP, that is at room temperature pressure, 1 mole of any gas occupies 24 dm cube. 1 mole of a gas occupies a volume of 24 dm cube. Therefore, X mole of a gas occupies a volume of 0.192 dm cube. The cross, what you will get? We will get 24x is equal to 0.192 or x is equal to 0.192 divided by 24. 0.192 divided by 24. and this will be 0.008 moles. 8 moles. So simply we need to multiply these moles with the molecules in order to get the molecules of carbon dioxide. 0.008 into 6.02 into 10 is to the power 23. What we will get? 0.008 multiplied by 6.02, 0.04816 into 10 is to the power 23, or 4.816 into 10 raised to power 21. This will be the final answer for this question. B. Complete combustion of fuels such as gasoline makes carbon dioxide. One of the hydrocarbons is gasoline, has a molecular formula C9H20. Construct the equation for the complete combustion of C9H20. You know, during complete combustion, we'll get carbon dioxide and steam. This is the reaction. C9H20 plus O2 gives CO2 plus H2O. Now let's balance the reactants and products. We have 9 atoms of carbon on the reactant side, so I will write 9 moles. I will take 9 moles of carbon dioxide. What about hydrogen? It's 20 on the reactant side, so I need to write 10. 10 moles of water. What about oxygen? Oxygen, 9 to the 18, 18 plus 10, 28. So it must be 14 moles of carbon dioxide. This is balance. C. Higher levels of atmospheric carbon dioxide lead to increased global warming. Number 1, give one adverse effect of global warming: melting of glacier ice, or rise in sea level. Will experience climate change. Number 2, describe how the presence of gases such as carbon dioxide in the atmosphere causes global warming. Carbon dioxide absorbs thermal energy from the earth and reflects it back to the earth. So in this way, it stops the loss of thermal energy into space. Absorbs thermal energy, reflect or releases, emit thermal energy towards earth. Emission of thermal energy towards the earth. In this way, it prevents the loss of thermal energy into space. Number D, carbon dioxide is removed from the atmosphere by photosynthesis. State the word equation for photosynthesis. The word equation involves the reaction between carbon dioxide and water. So products will be glucose and oxygen. Carbon dioxide plus water gives oxygen plus glucose. Moving to next question. Number 10. Proteins and PET are polymers. Proteins are polymers made by a reaction called condensation, polymerization. The diagram in figure 10.1 shows the structure of a section of a protein. This is a structure of protein, figure 10.1. One, draw the general structure of the amino acid monomers used to make proteins. So we will take the 1 unit, and it must be having C double bond O, and we have box here, and H. So it must be having OH here and H here. So for this box, you can even draw CH2 also if you want, instead of drawing the box. Number 2, proteins are polyamides. Name one other polyamide in your syllabus. It's nylon, so simply write nylon. B, PET is a polymer used to make plastic bottles. The diagram in figure 10.2 shows the structure of PET. The structure of PET, figure 10.2. This is the structure. Number 1, name the linkage present in PET. Here's the linkage. It's known as ester linkage. So write ester here. Number 2, proteins and PET are both made by condensation polymerization. Describe the differences between condensation polymerization and addition polymerization. So you can refer the formation or involvement of monomers. So in addition, in case of addition polymerization, involves joining of monomers with no other product, with no other product, while in case of condensation, polymer involves the joining together with the formation of simple molecule like water or hydrogen chloride. Condensation polymerization involves joining of monomers with the release of a simple molecule like water or hydrogen chloride. Now you can write other differences also, like in case of addition polymerization, there is the same empirical formula of the polymer as the monomer, but in case of condensation polymerization, we don't have the same empirical formula as the monomers. So for addition polymerization, we have same empirical formula of polymer as of monomer. In case of condensation, does not have same empirical formula as of monomer. You can also refer the presence of different or two function groups in case of condensation polymers, but in case of addition polymer, we have only carbon-carbon double bond. It involves carbon-carbon double bond. So here it involves two functional groups. Moving to next part. Number C, describe two environmental challenges caused by the disposal of plastics such as PET. So you can write any two from these, like accumulation of plastics in ocean, formation of toxic gases during burning. Accumulation plastics in oceans or formation of toxic gases when burned. You can even write landfills, that's responsible for land pollution. Responsible for land pollution. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.